everyone. So yeah, again, my name is Jenna, and I'll be talking to you today about the linguistic relativity of programming languages, which you just got a hint about what that means, but I'll explain it in a little more detail in just a bit. So, some facts about me. I'm an engineering manager at DigitalOcean. If you're not familiar with DigitalOcean, we are a simple cloud computing platform. I'm also an organizer of Empire.js, which is a JavaScript conference that happens every year in New York City. And you can find me at Zeigen Vector on Twitter. So feel free to tweet questions at me, tweet nice things at me, whatever. I'll also post the slides there when I get off the stage. So what we'll be talking about today are these things. So first, I will explain to you what linguistic relativity is, as well as say if it applies to programming languages. Spoiler alert, it does, or else there would be no talk. So yeah, I'll also talk about some things that famous computer scientists have said that shed some light on this whole thing. No one in the past has really explicitly said linguistic relativity of programming languages, but some people have said some things about how the programming languages they use affect the way they think. So I'll also talk about how linguistic relativity applies to programming languages as I see it, as well as what this means for us as polyglot programmers. So this linguistic relativity thing. So once upon a time, there were two men named Edward Sapir and Benjamin Whorf. And they came up, or history says that they came up with something called the Sapir-Whorf hypothesis. Well, this is a bit of a misnomer. This whole thing was really just Whorf's idea, and Sapir was just his mentor, and he really had nothing to say on the matter. And side note, this Whorf pun is not an accident. The character was named as an homage to the linguist, which is pretty cool, because of the whole Klingon being a real language thing. So the Sapir-Whorf hypothesis, finally, says that the languages you speak either determine, which is the strong form, or linguistic determinism, or influence, which is the weaker form, or linguistic relativity, the way that you think. Now, linguistic determinism has largely been disproven. It's kind of naive to think that the languages that we know totally restrict us from learning certain things that there are no words for within our language. But the weaker form, linguistic relativity, it's a little bit easier to get behind that. Though it is still controversial within the linguistics community, it's a little bit easier to kind of palate the fact that, yeah, maybe the languages that we speak, the words we have to talk about things, influence the way that we think about those things. So an example of this is the idea of basic color terms. So basic color terms are just single words that we use to describe colors. So in English, I happen to know, because I'm a native English speaker, that we have two words for this color gradient, green and blue. And having those two words allows me to break this spectrum up into two categories. The boundary kind of, wishy-washy here and it might be different depending on who you talk to, but there is a clear boundary, like one end of the spectrum is definitely green, and one end of the spectrum is definitely blue. But there are some languages that don't have two words. There's only one word for these, and though GRU is more of a linguistic toy than anything else, it kind of proves the point that some languages only have one word for this spectrum, so they see this only as one category. And in fact, there's some linguistic experiments that were done that showed that speakers with two words that bisect the spectrum, they're faster to discriminate those two colors when they fall into different linguistic categories than when they were from the same linguistic category. But this isn't a linguistics or psychology conference, so what does this have to do with code, right? Well, I would like to propose that the programming languages we know strongly influence the way that we think about programming. And this is because of some key differences I see between programming languages and natural languages. One really cool one of which is that programming languages create and manipulate the space over which you're thinking when you're programming, rather than just describe it. But this really isn't the case with natural languages. We are not wizards from Harry Potter. I can't say, Accio coffee cup, and one will come flying through the air towards me. That's like not the way that it works when you are talking. But I have heard a lot of people when they're programming, especially when they're just learning how to program, that they feel like it's magic, that they feel like wizards. And I think that has something to do with this fact that when you're programming, it's the language that you're using that you can use to kind of, change what you're thinking about. So as I said, there were some famous computer scientists that have something to say about language and thought and all of that. So Kenneth Iverson, who was one of the creators of the APL programming language, uses symbols, so kind of like emoji of the 1970s. He said that programming languages offer important advantages as tools of thought. And it's like the tools that you use are going to influence the way that you think about a problem. There's a saying in English that when all you have is a hammer, everything looks like a nail. So the fact that you have a hammer makes you think about the world in just a bunch of nails. Paul Graham also had something to say that relates to this in an argument that has come to be known as the Blub paradox. He said that some programming languages are more powerful than others. To motivate this argument, he supposed a imaginary but very average programming language called Blub. In this example, Blub programmers are very happy programming in Blub. They can get everything done that they want to using this programming language. They don't wish that it had any other features. They're perfectly content being Blub programmers. But they look at their friends who are programming in weaker or supposedly weaker languages, and they're like, how can you get anything done in that weaker language? It doesn't have X construct. Similarly, the Blub programmer looks at programmers in stronger languages. Paul Graham really likes Lisp, so you just assume that that's what he's talking about here. Oh, it has all those extra things, but I'm perfectly fine programming in Blub. I don't even really understand those constructs, so how important can they be if I can get everything done that I need to in Blub? And then the Lisp programmers apparently look down at the Blub programmers and are like, how do you get anything done in Blub? So more concretely, Paul Graham says, I look at programmers of Python, Java, C, and Perl. How do they get anything done in them, he thinks, without macros? And here's where I admit that I am a diehard JavaScript programmer, and I therefore have very little insight into what a macro does. But the internet told me that they allow for arbitrary extensions to the programming language, which you can drop into your code later, which sounds pretty cool to me. I would like to have that in JavaScript. So anyway, Paul Graham says that these programmers are satisfied with whatever language they happen to be using because they dictate the way they think about programs, which sounds kind of like linguistic determinism to me. I think that's a little strong of a statement, but that's cool, Paul Graham, if you want to think that. And he thinks this because he knows it from his own experience. As a high school kid writing programs in BASIC, that language didn't even support recursion, and he didn't miss it at the time because he was thinking in BASIC. So no programming language talk is complete without a Dijkstra quote. So here's one. So Dijkstra had some stronger, saltier things to say about BASIC, which is that people who have used it are mentally mutilated beyond hope of regeneration. Okay. Really? Like, mentally mutilated beyond hope? I mean, right? Like, Paul Graham was able to rise above his basic roots and, become an advocate for the most powerful programming language in the world, Lisp. So, kind of with that and all that talk about macros and recursion, I would like to slightly amend my previous linguistic relativity of programming languages proposal and say that we are influenced by the constructs and idioms of the most powerful programming language we know, not the languages themselves or whatever language we happen to be using at the time. And this is because of three more key differences that I see between programming languages and natural languages, the languages that we speak and write on a daily basis. The first of which is that we can easily learn more programming languages and how to program in them idiomatically. This is not really the case with spoken natural languages. It's really hard to learn a new language, especially as an adult. As a kid, it's really easy because your brain is pretty much just this language learning and learning other things machine. It's what's called plastic in the neuroscience literature. So as a toddler or even as a baby, you're just like programmed to learn languages. But as an adult, that goes away and it becomes a lot harder to learn second languages. Like I'm from the United States, so I learned English first, and I only started learning second languages in high school, and I don't remember any of them because my brain wasn't plastic, wasn't programmed anymore to be able to learn those languages easily. But I'm willing to bet that none of us learned how to program as babies. But yet, we are able to learn programming languages pretty easily. Even if you don't know one very well yet, guarantee you'll be able to learn a programming language within the next year or two. And on a sadder note, if you don't learn any spoken language by a certain age, you're doomed to never learn any. They found this out by accident, not by running experiments on small kids. Don't worry. So an example from my past is, so I started learning how to program as a third year in university. So they thought that Java was a good language to start teaching us with. So we learned for loops first, which seems pretty standard. And I thought for loops were awesome. They felt so powerful, I could just speed through arrays with ease. And then I took an algorithms and data structures class, and they taught us Python. And with Python came list comprehension. And that blew my mind. It was amazing. So tense, so terse, so short, so few things I had to type. Then I graduated, and I had the privilege of attending the fall 2012 batch of Recurse Center, which is a 3-month writer's retreat for programmers. And I was writing my Python and starting to learn JavaScript, but my friends were writing and learning functional languages. And they were like, "Do you even map, bro?" And I was like, "No, what's that?" But I soon learned that map was super awesome, and now I reach for it as much as I can. So moving on to a second difference between programming languages and spoken or written natural languages, just that we can implement the constructs of more powerful or even just different languages in whatever language we happen to be using. This doesn't really happen with spoken languages on a personal level. Like, I can't return from my trip here in Poland with some cool new Polish words and use them in my everyday speech and expect my friends and coworkers to understand me. But that's kind of what you do when you introduce a new library into your code and expect that your friends and coworkers can do code review for you. This classically happens with libraries, but also in languages like JavaScript, where the future isn't yet now and there's some weird spec stuff. This also comes up with source transformations and precompilers like Babel. So Guy Steele has something to say that I think is relevant here, which is that we should now think of a language design for being a pattern for language designs, a tool for making more tools of the same kind. Which is to say that we have a language and we are not restricted by the language itself. You can make new things and add that back into your normal everyday lexicon and be able to think in the ways that you want to think. So an example of this from JavaScript is underscore Lodash as a library. And this kind of comes out of that weird fact with JavaScript where you don't really have control over the execution environment, especially in the browser. So you don't know what ECMAScript spec implementation your users have. So underscore and Lodash and other libraries help to allow you to use whatever you want to use. So in this case, whether or not I'm using underscore.map or the native array implementation, I get to think mappily, and my users get to not have broken code if I want to think that way. So that's pretty cool. taking it one step further, there's this project that was put out by Mozilla a few years ago and introduced by James Long at JSConf 2014, so he could make emoji script, or the APL of this decade. It's called Sweet.js, which brings hygienic macros to JavaScript. So now I can have them and craft the language I've always wanted, which is pretty cool. And a more concrete example of what you could do with Sweet.js was make class syntax when it was less prevalent in browsers. So with all these things, the future can be now. In JavaScript, we have these specs that were ratified, but we don't yet know if our users have them, and they're maybe are not in our browsers or in Node. So with these libraries and with transpilation, we can use those things that we want to use. So the third thing is that programming languages are synthetic and can change. So with spoken languages, change is very slow. It happens over hundreds of years with very little regulation, and this leads to quirks and irregularities. Like, with all the jokes I make about JavaScript being weird, like, English is also pretty weird, right? It's not really deterministic, and that's because of the very natural evolution of the language. And we do on a wide scale get to borrow words from other languages, but this also happens very slowly. So like the word cafe that was introduced into English, I happen to know. Furthermore, while there are synthetic spoken languages, they tend not to catch on. I personally don't know any Esperanto speakers. Does anyone here speak Esperanto? I see like 2. So yeah, they're not super popular. And so here's a funny story about me. When I was a little kid, I used to think that the words that went into English were decided on by a group of people sitting in a room, like English experts, that were like, okay, yeah, we can put that word into English. That's not really the case with spoken languages so much. I know that happens occasionally, especially when deciding what word should go into the dictionary this year. But from what I understand, this is what TC39, the standards body of JavaScript, does. They review proposals and say, yep, that could go in this time. So an example of the evolution of programming languages, I will also pull from JavaScript, since I know it well. Loops have been around for a while. And then in ES5, we got map. And more recently than that, in the ES 2015 spec, we got generators. And the one thing that was missing from my list of favorites from the beginning is array comprehension. And while this was being used by JavaScript programmers, it hasn't made it into a spec, and apparently won't. I tweeted about this a few days ago because I was curious, and Brendan Ike and Alan Werfs-Brock told me why, which is TLDR, arrow functions, and map types should be enough to help us create concise ways of doing this. So that's cool. If the experts don't want us to have array comprehension, I trust them because they're the experts. Guy Steele has another thing that I think is relevant here, which is that languages that can't easily grow will die. So if we don't let our programming languages evolve, we're going to lose people who have come to these languages from quote-unquote more powerful languages and have experienced and come to think in these more powerful constructs. They're not going to want to program in your language anymore if we don't allow these things into our language. So furthermore, growth allows for more rapid growth. And while that sounds pretty obvious, if you think about it, it's true. So the fact that now that JavaScript has generators, we can then create more efficient, concise methods of async, which is very important to JavaScript. So now we can create async await and communicating sequential processes, which are important to those people who program in Go and also like the core async thing in Clojure. So all right, so we could all leave right now and go learn Clojure. Does that sound good? No? All right. And then come back next year, and this will be MonoConf. It'll just be a Clojure conference. No? You don't like that? All right, so I have a different proposal, which is that y'all go out and learn new languages. This is PolyConf after all. Y'all are here because this is a polyglot conference, I'm guessing. So find cool things in those languages that you decide to start using and bring them back and share them with your programming language communities, whatever they happen to be. Because I tend to think that programmers are very thirsty for knowledge, no matter what programming language they are using. Like, we all want to learn new things, so we might not have access or insight, or we might even be a little bit too much of a beginner to understand more complicated programming concepts yet. But with help, we can learn them. And even if they don't exist in the language that you're using, that's why we have libraries. So take that thing that you found that you really liked in another programming language and, write a library for it. That means you'll get to learn the innards of that favorite construct pretty good. So this really is important to me as a member of the JavaScript community, because there's such a wide array of people in there who have such a wide array of skill sets. Right? JavaScript is a language that people tend to use when they're teaching beginners how to program. But there's also people who have been programming for decades, and they like JavaScript because there's reasons to like JavaScript. But even very few of those people have clout with ECMA. They're not on TC39. So they have to make libraries too, just like you. But what I'm not saying is that we should have one programming language to rule them all. There's a reason why these programming languages exist. They are good at certain things, and they evolved to be good at those things. So even though I'm like, yo, bring back all of these cool constructs from other languages, keep your favorite programming language a little weird. All right, so slides will be there. I'll tweet it. Also, there's a kind of old blog post on this at that link. Tweet at me at Zeigen Vector. Thanks.
Thank you for the talk. I come from academia, so I apologize.
Sure.
I agree with the premise about programming languages affecting the way we go about providing solutions to problems. And I think to this end, we have failed in academia, at least in Canada, where I come from, in our curriculum design. We start teaching a language, and we take you from hello world to if statement, while loop, for, oh, here's a class. Language number 2, hello world in language number 2, if statement. So by semester 2, most of our students decide not to come to class anymore. So what we should be focusing on, in my opinion, should be the principles of a programming language, not the syntax per se. So what is different in a language? What does a language contribute in terms of concept and principle? So just a comment that I fully agree. I think you made a very important premise. Thank you for the talk.
Thank you.
Well, I was just wondering what your opinion is. So programming languages, they start to age. And then inevitably, after they start to wane in popularity, there's always someone who says, okay, we need to add X so that it catches up with new, more modern programming language. Do you think that should be the goal, or should old languages just sort of die gracefully and stay as they are, and people should move on to new ones?
So as I mentioned at the end, programming languages exist for a reason. If their use case has been taken over by another language and no one's really using it anymore, I don't see any reason to keep them around if they don't provide anything particularly new to the programming community.
So I wanted to sort of take the analogy of the natural language to programming language. You said about how the programming language affects how we think, and how we think affect the programming language. It's vice versa. So, like in a natural language, there's a quality of aesthetics and the quality of the playfulness. So you just you use the language and you toy with the language. Now programming languages are there to instruct the machines to do what we want them to do. So what do you think? Is there a value in the syntax for a syntax for its own benefit, or for the constructs that just look elegant but are seemingly useless, possibly?
So I was coming at this more from my cognitive science background, which is why I'm qualified to give this talk. I think cognitive load is very important for programming, especially when you don't want having to when you're reading someone else's code, you don't want trying to decipher what that means to get in the way with thinking about the logic. So I think that there is something to be said about aesthetics in programming languages, which is I think why a lot of people prefer Python to Perl, right?
What about languages that are great at solving just one problem but useless on their own, like Prolog, for instance?
Like what? I'm sorry.
Prolog, for instance.
I think that predates me a little bit. I mean, if people want to use them for what they're good at, and it's not trying to keep an old horse alive, then sure. If they keep something good in the programming language community, I think it's cool. We all have our hobbies.